Okay, this is section 9.1, and we're going into a chapter on probability and statistics. Just want to give a special shout out to Miss Gordon for helping me with these notes. These are actually hers, and I get to use them, so thanks, Miss Gordon, for your help here. So in our first section of studies, we have this learning outcome called I need you to understand the role of probability in society. Why do we even care about probability, and how is it helpful in our lives? Well, to begin our studies, you should really know what probability means. It probably refers to the likelihood that an event will occur. So, really, sometimes we call this the mathematics of chance. And today I want to show you that there are three forms. The first one is called the experimental probability. And that's the probability you get when you calculate it from an experiment. So what you are doing is you are observing results and then making a tally or figuring out how many of that type of thing happen. So you're looking at large number of observations, and you need large numbers to represent or reach an accurate calculation. So here's an example. Sometimes when you take a paper clip, you can slide it off the edge of the table, and it falls on the ground, and it'll land three ways: either on its side, either open up, or open down. And let's say I did this experiment a whole bunch of times. In this case, 24 plus 10 is 34 plus 16. That's a total of 50 times. Okay. So the question is, what is the experimental probability it will land on the side? So on the side, we have a frequency of 24. That means out of the 50 times, 24 of them happen to land on the side. And if you calculate that as a percentage, that's 48%. So 24 out of the 50 is 48%. Another example here. A die was rolled 1,000 times, and a 1 showed up 240 times, and a 2 showed up 58 times. And in this case, what's the probability of rolling a 1 or a 2? So if it's a 1 or a 2, I'm going to say there are 240 and 58 together. And that equals to, I think, 298. And so 298 out of 1,000. And that as a percentage is just 29.8%. So then looking at the experiment, looking at those numbers, we can find experimental probability. Then we have something called theoretical probability, and that's based on a mathematical model based on all possible incomes. This is what you did last year in Math 8, where the probability is calculated as follows. You want to count the number of successes, and please write this down, and you want to divide that by the total number of possible outcomes. And that's the general idea of calculating theoretical probability. Okay, so it's just a ratio. So, example C here is, what's the probability of getting a 1 or a 2 and rolling a 6-sided die? We'll count the number of possible successes, a 1 or a 2, so there are 2 possible successes. And when you roll a 6-sided die, there are 1, 2, 3, 4, 5, 6 different options, or 6 possible outcomes. So your fraction is just 2 out of 6, which reduces to 1 out of 3, and if you want a percentage, that's like 33.3%. Okay. Now, part D says Carl randomly surveys 100 students about their favorite subject, and there are actually 500 students in the school. And here's his results. So when you see his results here, this is actually not theoretical. This is the experimental probability, because he actually did the experiment. He asked people and collected data. If I'm asking for the theoretical probability that the student chooses math, well, there's 4 choices here. So think of a pie, and you're splitting it up into 4 choices: math, English, history, and science. Well, out of the 4 choices, how many are the successes? It's just math, that's 1. It's 1 out of 4. Okay, or 25%. Once again, there's an assumption here. The assumption is you're assuming each subject is equally likely to be chosen. Right? My pie here is broken into 4 equal parts or pieces. Now, based on the survey results, so here's that experimental part probably coming in again. Predict how many of the 500 students prefer math. Well, in this case, the probability is equal to the number of successes, which is 30, divided by the number of total students chosen or randomly selected, which is 100. So in this case, that's 30%. But I want to ask you to use this to predict how many of the 500 students prefer math. So now you need to take your 30% and multiply that by 500. Or take 0.30 times 500, and I think that gives you 150 students. So therefore you can say out of 500 students, based on my results, I would expect 150 of them to like math. Alright, turn the page. So a third type of probability, and this one's not talked about very much because it's not that great, is what we call subjective probability. And this is where you're basing your probability on an educated guess, an estimate, judgment, or that gut feeling you have, or some belief. So here are two examples. Like when you're flipping a coin, the theoretical probability is 0.5 because there's only two sides to the coin. So there's 1 in 2 chance of landing up heads, which of course is 50%, or 0.5. Now, despite knowing this, you still may feel strongly that your coin will land up on tails, because you just feel like this coin is more heavy on the tail side. So because you feel strongly, that leads to that subjective probability. Or how about the next one? You think I collect math homework the last 2 classes, so therefore you're hedging your bets that I won't collect homework again in the 3rd class, so you're not going to do your homework. Well, what's the problem here? Once again, you're using that subjective or gut feeling that you think that I'm going to do that, but you never know, and there's no theoretical ideas to back that up. So lastly, we talked about the different types of probabilities, but we also should talk about assumptions. So when we make a decision based on a fact, we take certain things for granted. And when we do this, we make what we call assumptions. That is, we do not look for hidden reasons or other explanations for our thoughts. So here's an example. The Health magazine claims that people who exercise 3 times per week for an hour reduce their risk of developing heart disease by 40%. Whoa! So Monique, she plays soccer 3 times a week. That's exercising 3 times a week for an hour each time. So therefore Monique thinks that she's reduced her risk of developing heart disease by 40%. So what assumption is Monique making? So think about it. How can she say, well, because I exercise 3 times a week, my heart disease is going to drop by 40%? Really what she's doing is she's assuming nothing else matters. So assuming nothing else affects the risk of developing heart disease. You may be thinking, well, what else affects heart disease? Well, perhaps other things affect it. So other things such as, what do you think affects your heart disease risk? Maybe your diet, like what you eat. Maybe your family history, like your genes, your gene makeup. Right? Maybe even the amount of sleep and stress that you have. Those could be factors too. So may also affect the risk of heart disease. So really, she's assuming that all these other factors don't play a role. And that's most likely not true. Alright, next one. Sandra. She passes 6 of the last 7 science tests. Yay! So she's sure that she'll pass the next one. So what assumptions is she making now? Well, perhaps she's assuming the tests are all equally difficult. And that might be the case, but might not. Okay? She's also assuming she studies just as hard. So these are just 2 assumptions. You might have more, but there are many other assumptions that you're assuming before she can make that conclusion. Alright, so that's the beginning of probability and statistics. We're going to be learning more about this stuff and how to do a survey later on down the road, and we're going to culminate this unit with a large project, so stay tuned.